Have you ever looked up at the night sky and just wondered about those peaceful, twinkling stars? Well, welcome to this explainer where we're going to uncover a massive, explosive secret. You see, when you look up on a clear night, the stars look totally calm, right? Almost like they're just sitting there, eternal and unchanging. But what you're actually looking at are some of the most dramatic, action-packed objects in existence. Today, we're going to break down exactly how these giant celestial forges operate and how their spectacular deaths actually created the very building blocks of our entire universe. So, it really brings up a fascinating question. Why do the calmest-looking stars in the sky suddenly trigger the absolute biggest explosions in the universe? To solve this mystery, we have to take a trip deep inside a massive star and witness an epic billion-year-long wrestling match. It's a battle between two of the most powerful forces you can imagine. And for millions, sometimes billions of years, it's a perfect tie. But when that tie finally breaks, the result is absolutely mind-blowing. Section 1, A Star's Secret Battle. The Hidden Cosmic Wrestling Match. Okay, I want you to imagine a star, not just as a glowing ball of light, but as a roaring, giant arena where two invisible forces are locked in a struggle for survival. This whole story starts deep inside a massive cloud of space dust and gas called a nebula. Over millions of years, gravity acts like a giant, invisible hand, just pulling and squeezing all this gas together. As more and more material gathers up, it gets packed in so tightly that the center of this cloud hits a mind-blowing temperature of 15 million degrees Celsius. That is millions of times hotter than the oven sitting in your kitchen right now. At this incredible heat, a giant cosmic factory turns on. This factory uses a process called nuclear fusion. Basically, the star starts violently smashing tiny hydrogen atoms together to build slightly heavier helium atoms. And every single time this smashing happens, it releases an enormous amount of energy. Think of it like millions of tiny, powerful engines suddenly roaring to life, pushing massive amounts of heat and energy outward from the center of the star. Now, have you ever played a game of tug of war? Because that perfectly illustrates what's happening here. On one side of the rope, you have gravity relentlessly pulling everything inward, trying to crush the star into a tiny little point. On the other side, you have the incredible energy of nuclear fusion pushing outward, trying to blow the star apart. For billions of years, these two forces pull with the exact same strength, keeping the tug-of-war rope perfectly centered. And that perfect balance is exactly what keeps the star stable and shining brightly in our sky. Section 2. Running out of fuel. When the cosmic gas tank hits empty. But just like your family's car on a really long road trip, a star just can't run forever. Let's see what happens when the star's cosmic gas tank starts running low. As the star gets older, it slowly uses up all its hydrogen fuel. It's exactly like your car running out of gas. With less hydrogen available, that nuclear fusion factory has to slow down. And when the factory slows down, that super powerful outward push of energy starts to weaken. Here is the catch, though. Gravity, it never gets tired. It doesn't need fuel. It just keeps pulling inward every single second, day and night. So as the outward push from fusion gets weaker, gravity starts winning the tug of war. It squeezes the star's core tighter and tighter, making it smaller, incredibly hot, and super dense. Section 3. The Big Iron Problem. The element that breaks the machine. Now, massive stars don't just give up when the hydrogen runs out. The dying star actually desperately tries to survive by creating heavier building blocks. To keep that outward push going and fight off gravity, the star starts fusing heavier and heavier elements together. It's kind of like switching to different types of emergency fuel just to keep an engine running. It fuses helium, then carbon, oxygen, neon, silicon, building up step by step all the way down to iron. But iron? Iron is the ultimate trap. It completely breaks the star's machine. You see, fusing all those other elements released energy, which pushed outward against gravity. But fusing iron actually steals energy. It requires energy to happen instead of making it. So the very moment the star tries to fuse iron, the outward pressure completely shuts off. With the outward pressure completely gone, there is absolutely nothing left to hold up the heavy outer layers of the star. Gravity instantly wins the epic tug of war. The star's massive core, which was fighting so hard for millions of years, collapses inward in less than a single second. I mean, just blink your eyes. That is literally how fast gravity wins. Section 4. The ultimate space explosion. The biggest boom in the universe. This sudden, violent collapse sets the stage for a light show like no other. As the massive outer layers of the star come crashing down into the superdense center, they hit it so hard that they literally bounce off. This bounce is driven by a massive rush of billions of tiny particles called neutrinos. The outer layers get blasted back out into space at millions of kilometers per hour. And this gigantic, unimaginable explosion, that is what we call a supernova. The sheer power of a supernova is honestly almost impossible to wrap your head around. For a few weeks, the light from this one single exploding star is so incredibly bright that it can actually outshine an entire galaxy filled with hundreds of billions of normal stars. Astronomers can see these bright flashes from millions of light years away, all across the universe. Section 5. You are star stuff. The magical rebirth. Now, this distant space explosion isn't just some cool light show far, far away. It is actually directly connected to you and me right here on Earth. Seriously, hold out your hands and look at them for a second. During that massive supernova explosion, the intense heat and pressure created heavy elements and blasted them way out into deep space. That means the iron flowing in your blood, the calcium making up your bones, the oxygen you are breathing right this second, and even the gold in your family's jewelry, every single bit of it came directly from a giant star that exploded billions of years ago. About 4.6 billion years ago, giant clouds of these scattered elements, these amazing recycled building blocks from ancient supernovas, were pulled together by gravity. Over time, this swirling cloud of recycled stardust formed our very own solar system, our planet Earth, and eventually every living thing on it, including us. As the famous astronomer Carl Sagan so beautifully put it, we are made of star stuff, and modern science proves that this is a literal fact. You are a walking, talking collection of atoms forged in the greatest explosions the universe has ever known. How cool is that? Section 6. What is left behind? The strange cosmic leftovers. But wait, what actually happens to that crushed core left behind after the spectacular supernova explosion clears out? Well, depending on how big the original star was, that crushed core becomes one of two incredibly bizarre objects. It might become a super-dense neutron star, packed so tightly into a space just 12 miles wide that a single teaspoon of it would weigh billions of tons here on Earth. Or, if the star was even more massive, gravity just keeps crushing it until it forms a black hole, an object with gravity so extreme that not even light itself can escape its pull. Which leaves us with this final thought. When we look up at the night sky, we aren't just looking at the past, we are looking at the engines of the future. The explosive end of one massive star is just the beautiful, violent beginning of countless new worlds, new planets, and potentially new life. So what new, unimaginable worlds will today's dying stars create billions of years from now? Keep looking up, never stop asking questions, and always remember the incredible cosmic journey of every single atom inside you.